So you guys have been learning so far from the big picture that there are two main ways that rocks change. They change through plate tectonic movement, which is a different lesson, and weathering. And we're going to go over weathering now. Now, weathering is simply exposure to everything that's on the surface of the earth. And that means everything. Things from space, water, wind, rain, animals, organic matter, all sorts of stuff. Anything that's on the surface of the earth causes weathering. So weathering is breaking down rocks through two means. You can have physical means and chemical means, and literally the biggest difference that you always need to remember with physical and chemical is that when you have a physical change, you have the same substance in the end, it's just in different size pieces. Okay, so you're just chopping it up, but you still have the same substance. Whereas chemical change means you make something new, a new substance from a chemical reaction. And you're going to be going further into that as you go into chemistry, but you've already learnt that in basic sciences to begin with. So let's talk about physical change. So the biggest thing that really does affect rocks and all of the, well, basically everything around them is temperature. Because temperature affects what happens with the atoms. Atoms themselves, I'm just going to squish in here. Atoms sit together. And depending on their temperature, that actually affects the distance between them. As they get hotter and have more energy, and they start to try and move around a bit, they can't always, but they do try. As they heat up and they get more energy, they push each other apart, and that causes what we call expansion. Now this happens in every substance, okay? And it will either expand and contract and get bigger and smaller, or it'll try and expand and crack. Either way, it's going to cause some changes around it. And that temperature change really does affect our rocks. So let's have a look here. We've got temperature causing expansion and contraction. That can happen in the rocks themselves as they heat up and cool down. It can also affect them because of substances that have slipped inside the rocks, like water, which then turns to ice and expands and contracts, and the ice can crack the rock. You can also have water dissolving the rock, because it does tend to dissolve certain minerals that are in the rock. Anything that's a salt that is easily dissolved in water, like your table salt, I mean, that's actually a mineral that makes up rock. So any of those salts will dissolve if water's there, and that will help break them up. Other salts will not only dissolve the rock, but if the water they're dissolved in evaporates, they'll actually start growing again and filling up cracks and breaking the rock apart. And a few other things. You've got wind, which tries to sandpaper the rocks down, and living things. And you must know, honestly, you're a living thing. You make lots of mess and you break down lots of stuff. You think about the wear and tear that you yourself cause on the rocks and the soil around us. Anyone that's had a look at animal tracks and what they do to the mountainsides and that knows that we're pretty darn good at breaking down rocks. Let's have a look at a few pictures here. So here I've got a picture of water inside a little crack in rock. Now we did a demo on this. If you freeze that water, it will expand, and because of that it'll push out on the rock and it will start to crack the rock. And you'll end up with two pieces of rock in the end. It'll eventually eat its way down until it completely breaks that rock in two. And the process will then start in other little areas where water can congregate as well. Now down here, this is the power of sand. Now this is a sandstorm. Happens in deserts an awful lot. Well, anyone who's been in a powerful sandstorm knows that it actually has quite an abrasive effect. We use sandblasting machines to take paint off cars, for heaven's sake. So imagine what happens with rocks which are continually exposed to wind, where the small particles are continually hitting them. It does actually wear away the rock. Now, last but not least is chemical weathering. Chemical weathering means that you have a chemical reaction happening on the rock. And we see this all the time. Whenever you see rocks that are starting to go brownish around the outside, that's actually usually what we call oxidization, where it's reacting with the oxygen in the air and causes oxidization or rusting of the rock. And that's the start of chemical breakdown. Also, there's tons of acid around the place. Anyone that's seen some of the European countries where they have a lot of acid rain, see how much it can eat away at what was once beautiful statues done by master stonemasons. A lot of the finer details are gone because of the acid rain. And of course, it's not just acid rain. You tend to pee a lot, so does every other animal on the planet. A lot of us actually release acidic compounds and we break down rocks. So here's some examples of what I just said. This is what an acid rain has done to some beautiful marble statue that was in a graveyard in Europe. Was once a masterpiece and now not so much. And last but not least, here's a good example of acid being released by an organism. Now, not all organisms pee in the same way. Okay, so yes, we do release urine because we're a large multicellular organism that moves around, but these guys here, these actually release acid too to eat away rock. These lichen, they actually eat the rock. And this poor rock here is screaming. They love to eat rocks. So they actually grow on rock, and as they do, they release acid into the rock, break it down, and then suck up the leftovers. And that's actually part of their diet. So that's why you see them growing on rocks all over the place. So that, in a nutshell, people, is weathering. So on with the show.